What else do you know about a circle graph? Yeah? Circles don't have corners. Good. What else? Josiah. Okay, good. What else do we call circle graphs sometimes? Pie graph. Good. Sydney, what else do you know? Anything different? It is not a quadrilateral. Good. And the circle itself represents 100%. Okay. So that's why they call it the pie graph, because when they take a wedge out of it or a piece out of it, it could represent different amounts. So if we had a circle graph set up like this, one of these wedges, well, they would each represent 50%, right? If you had a circle graph that was split up into fours, each of these wedges would represent 25%. The bigger the wedge, the bigger the, right, the percent, okay? The bigger the amount. Now, you're going to be constructing your own circle graph today. Now, this is a start, okay? That's a start. And I gave you the calculators today because there's going to be a way in which you can really get close on the size of the portions you're going to take out, okay? If we were speaking in terms of degrees for a circle, how many total degrees make up a circle? 360, right? A 360, if you spin all the way around in a circle, it's a 360, okay? Now, knowing that, how many degrees would be represented by each of these if it's 360 for the whole thing? What is a straight line? It's a straight angle, which is 180 degrees. The other thing here on this, you have those little markings which mean what? Right angles, which are 90. Okay? And it makes sense because 90, 90, 90, 90 all together equal 360. Right. Okay? 180 here, 180 there equal 360. So the degrees will also add up to give you the total of 360 degrees. Okay? All right. Now, let's get familiar with circle graphs with just some basic questions. Like, look at 343. Look at 343 in your book. Page 343. Now, you've no doubt worked with circle graphs before when you answered questions about them. So I'll be surprised if you worked with them extensively outside of that. So number one, which sport is the least popular? Down at the bottom of 343. Which sport is the least popular? Joe. Tennis. Yes, tennis is represented by the green in the graph, and it has the smallest wedge. Number two, which is more popular, basketball or volleyball, according to this graph? Brandon. Basketball. And list the sports from least to most popular. Least was tennis, followed by which has the next biggest wedge from tennis. Volleyball, followed by, and baseball, and soccer. Soccer's almost half, right? It's almost half. So you've worked with that and questions like that. Now, let's take a look at number 4. I'll write it up here for those of you that don't have a book. Okay. Says to make your own circle graph representing these three values. Okay. Now, we can put a circle. Let's see if I can. 12 doesn't work. There's a circle, right? Okay, perfect. All right. Now, we take a look at this and we say, I need to represent these three amounts. Where do you want to start? Which is the easiest one? 50. So if I put a point in the middle just as a reference, and I know if I go straight across, I could label that first either portion 50%. Now, as far as the 10 and 40 are concerned, is there an exact way to determine how many degrees each of these are going to use? Now, if you don't have protractors here with you today, we can still just kind of get a good guess, okay? An estimated guess. How many total degrees are in a circle? 360. We don't know how many degrees this is going to represent. Do you want to do the 40 or the 10? 10. Fine. 10 over 100. Why 10 over 100? 10%, right? Anytime we put a percent into a fraction, we always put 100 at the bottom. What we have here is a ratio. You have a calculator. Give me the missing value. Okay. What do we get for about how many degrees is the 33%? About 120, right? About. How about the 14? Did you do the 14?
No, I didn't do it.
60?
How about it?
50? All right, let me just double check. It is 50? 50, yeah, 50. And then the 5 was what? About 18, right? 18 degrees. Now, again, we can just use this as a reference. We know what 50 degrees looks like. So once you get it to this point, you can kind of work with what's easiest. If I know that in a right angle, halfway is 45, do I have like an imaginary, can I make an imaginary right angle right here? Right here I've got one. So if I were to go about halfway, I could label one of these pieces as 14%. Okay. Now, from there, I can say, okay, I'm going to have this whole big wedge here that's left, 120 degrees. If I know that this is what kind of an angle is greater than 90, what do we call that? Obtuse, good. So I know that if this is a right angle, it has to be bigger, okay? 120. All right? So I kind of have one here, but I need to leave enough room for an 18 degree. So I can make sure if I bring back my imaginary right angle for this one thereabouts, okay, I can give myself another wedge there for 5 and call the rest of it 33. Okay. So work okay? So it's all about size relation too. This one, this 5% should be about a third of this, right? I mean, 5 is just about a third of 15, right? That's 14. So just try to think of things in relation to size as well. Now, if you had a protractor, you could get it perfectly, but I don't need it perfect for today. I just need you to have at least a solid idea and not just take these circles and just start drawing spokes on them, right? Yeah. Mm-hmm. Yeah. Take a look at your worksheet. It's on the back of 7.4. Take a look at it. So they give you the circles. So again, you don't have to worry about drawing the circle. Sketch a circle graph for the given percent. So number 1 is favorite foods. So you've got pizza 60, spaghetti 30, hamburger 10. Yeah? Three 360. Well, you've got everything you need with the calculators aside. That's why I gave you the calculator today. Okay? The hard work is being done for you by the calculator. All you've got to do is just get an idea of, it's just an idea. It's just a rough idea of what you should have. Okay? I pulled out the protractor on like the first one, but as long as you have an idea of what these angles should look like, that's all I'm asking that you do on the circle graph. That's all. So let's look at number 1. Pizza is 60. The spaghetti was 30. And the burger was 10. Okay? So we bring out our circle. And we go from there. So why don't you take your calculators, get them set up, at least get the degrees for each of them, then we can deal with that, okay? For degrees for pizza. How many degrees about? What was it? About 216, right? How about the spaghetti? Kishana? 108, it's fine. And the burger was 36, okay? So now what it comes down to is this, when you look at those, okay, knowing that the entire thing is 360. Now, 216 looks a little bit big, 108 looks, well, it's obtuse, but how about the 36? Is that something that you can work with? Then maybe you want to do that one first. 36 looks like that 45 degree. Remember we said if this is 90, right? So if we go ahead and make ourselves a line here, we could call this one the burger. Okay? Close enough. From here, now it's your choice between picking the 60 or the 30, which might be easier. I think the 60. And I'm going to use this line, and I want to get this whole half plus a little bit more. Okay? So if I go like this, I got this whole half, which is 50, plus like another. Does that look similar to this side? Sure. Close enough. So that was pizza. And then what's left is your spaghetti. Okay. Not bad. Okay. Do you understand the degrees? If you have 3 of them, How many of them do you have to understand? 2. You only have to understand 2 of them. Because if there's 3 total, and you take care of the 2, what's left is going to be the remaining percent, going to be the remaining degrees. So if you look at, this might be the smart play, find out what the degrees are that you're working with, use the ones and pick out the ones that you think are going to be easiest, and then go from there. We didn't have to really mess with the spaghetti one at all, okay? But we just had to make sure it was 108 degrees. Is that an obtuse angle? And not by much, but it didn't have to be, right? Because 90 would be, right? Has to be greater than 90. Okay? So I'm going to assign the rest of the worksheet. Label them like we did up here. With the, don't put pizza and then put 60%. You don't need to. Why don't you need to put the 60% for the pizza? The size of the wedge is supposed to tell you that. Okay? All right, and then 7 through 9, just answering the questions that are on the graph there. Okay? So you got about 15 minutes with my calculators before I'm going to take them back. So you might want to do all